I forgot to click the record on it. Yeah, to sanitize all the strings. So what it actually does is I can explain later. And then in Python, so that there is a library that accesses multiple database, not just for MySQL, SQLite, and then there are like the wrapper for like the database SQL execution. And then in Python, we operate on the cursor. So there is a connection. Connection means that the interface to talk to the database. And then cursor is like the one of the execution of the query. And then in doing that, we can pass this kind of the string arguments as a tuple. And then, so we are not putting the name directly to this kind of a string using the Python method. So internally in this function, the cursor.execute, they actually apply the sanitization mechanism to name variable and then put the secure string on the name. Yeah. So the correct way to defeat the SQL injection is that in each of the web framework, there is a function that you can escape the string for the good SQL, secure SQL use, and then please use that. So some other bad examples are, so even if we use the cursor.execute, so if we directly add the username to the query string, that's no good. And then this is also Python method to print the username into this string. That is also not good because there's no sanitization at all. So if the attacker put quote on it, then they can break the query string. Yeah. And then internally, what does this sanitization do is they try to find any kind of special character that could interfere with the SQL execution, and then try to change all the characters with the added with the backslash. So in the most of the programming language, we regard the backslash as a special character to have another meaning of the character. So backslash quote will not be regarded as a quote for string. So that's why like we can defeat like a breaking of the string literals in the quote SQL query. And then same thing for the this kind of the double quote. And then same thing for the backslash itself. Yeah. So like it actually escapes all the special characters. For example, some other SQL query uses a dollar flag as a special character, so they also escape the dollar flag for that. Yeah. So the thing is, like those APIs are thoroughly evaluated, and then try to remove, like try to escape all the special characters that affects on the SQL query's execution. So yeah. So the purpose of doing this is like they're not letting attackers putting their input as a SQL command, such as select or that kind of thing. So making just the input as regarded as just string. So those kind of the sanitation mechanisms for that. Yeah. Any questions about defeating the SQL injection? And then because the SQL has a lot of problem like this, either we need to use a sanitization mechanism well, or we can use a totally different database. And then there are databases so-called the NoSQL database. So it's quite funny, but the reason is like there is a database that can store the data as just a key and value. We just call it as a key value store. And then in that case, we don't use SQL query. So we just use databases, something similar to Python dictionary. So if we provide a key, then it will give the data. And then there's no SQL at all. So if we use NoSQL, then there's no SQL injection. So that's the one of the thing. But another problem is like there are attacks in NoSQL. So then we call that as a NoSQL injection. So this similar thing happens. So for that part, we need to sanitize the key part of the thing that goes to the database query. And then for next, we will learn about like how the web servers are managing our login status. So we learned about like after we provide username and password, server will run this kind of query and then check if the same hash value is stored into the database. If so, server need to store something to indicate that the current user has been logged in. And then how server does that to maintain like the login status or user status is that, so they are doing with some of the token called cookie. And then cookie can be issued by the server and then delivered to the client web browser. And then web browser automatically manages for each of the website. And then whenever we send the request to that specific server, then they will include this cookie value to all the requests. And then let's take a look at how that kind of the interaction works with the server. So suppose there is a web browser and the server. And then we type the username and password, send that to the server. Yeah. And then server will do hash and then checking with the database. And then if the database row matches with the hash of the password, then what they will do is internally, they will create a so-called session. So this is just a conceptual thing. So the session is some of the storage in memory. Then just marking that, oh, the current user, this one, is login with the username ABCD, something like that. Yeah. On the server side, we have a table of the thing, and then we will put the current client is logged in with this specific ID. Yeah. And then to do that, we need to have an identifier that which client you are. So for example, right now I want to log in as a blue9057, my username, but the server wants to know the unique ID for each web browser. So to do that, what they are doing is actually they are generating a cookie. So the cookie could be like a random string encoded in base 64, or it could store some of the data, but basically you can regard that as just a random number server generates and then only server knows, and then send that to the user. So server generated this kind of value, and then it will store my username blue9057 in the session dictionary like this. And then the server send this set cookie parameter to the client. Then the web browser will check this message and then store this cookie into their web browser. And then next time the client, the web browser, makes a request to the same web server for the different location, same domain, then the web browser keep track of like what kind of the set cookie was sent by the server. And then whenever it is sent, it will store into their own database and then attach that for every single request to the same web server. So to fetch the user info, now we attach cookie on it, then it goes to the server. Then what server can do is just to get this cookie value and then read about the sessions dictionary with the cookie. And then if the value is not existing, then the user has not been logged in. But if the value is existing in the dictionary, that means like a server previously stored the username, and then that means that it passed the legitimate authentication for the login. Yeah. That's how the server can keep track of like the client has this cookie, and then that cookie has been logged in previously, so that they can keep track of the kind of the login status about the user. So after having this, they know that the username is a blue9057, fetch it from the session, and then prepare this kind of response, and then send it back to the client. That's how we can keep track of like which user, which browser has been logged in. Any questions about this part? Yeah. So the cookie actually looks like this kind of just a random number and then encoded into the base 64. Yeah. And then it's so we are actually learning about session hijacking attack. And then please wait 10 more minutes, then you will see about that. Yeah. Yes. So I like this kind of the discussion, because like how I would like to design this class is like I will give some of the background about some of the thing, and then we will learn about like how it works, and then we also learn about how it could go wrong, and then we will also learn about how can we make it correct. And then I like that kind of thinking about like whenever you learn something, then how can we hack that? And then please don't stop about thinking it there. We also need to learn how to defeat those kind of attacks. Yeah. So we learned the new term cookie, and then the cookie is the way of storing the state between the client and the server. Yeah. The reason is like a HTTP protocol itself is stateless. They don't manage status. What it does is like we need to just send and receive, and that's it. And then not at the HTTP protocol, at the application, we need to manage this kind of session. And then how we are doing that is like if any kind of status, for example, if we manage the login status at the client side, if that is true, then any kind of attacker can mimic that, and then they can claim that they are logged in with the valid user. So that could be a disaster. So we need to make all the security related critical operations on the server side in that regard. So the server manages session and then mark the user has been logged in, but the identification of that kind of the which client it is done by the cookie value. Yeah. So another interesting thing about the cookie is that like a server will issue and then set it as like a set cookie entry of the response. And then whenever a user's web browser receives that, it automatically added to the cookie for that specific domain. So for example, if you log in to the www.example.com, and then they say set cookie message to us, then web browser will store that cookie to this domain. And then if I go to my.oregonstate.edu and log in, and then they will issue their own cookie. And then cookies cannot be mixed across the different domain, because the domain name means that like the owner of that server in reality. So that's why like we stick with that kind of a concept. Yeah. And then like this is how your web browser can use the same cookie value for the returning for some of the website. For example, if you log into Facebook and then close the web browser and then visit there 8 hours later, then the same cookie is still active. So that's why it does not require the new login. And then they can remember that like you have been logged in previously, and then it still works. And then another thing is like you have seen that in dual authentication at Oregon State. So you have seen that there's some of the checkbox, then you can make it to be alive for 12 hours, or it could be expired in 1 hour or something. So when we assign the cookie from the server, there is a feature that we can set the expiration time. So usually we set it as a 1 hour or something, but if we click that button box when we log into the Oregon State website with Duo, then that actually sets like cookie expiration time as 12 hours. And then you can easily guess about like how Facebook sets the expiration time. So it's quite long. That's why it does not require like the typing the username password again and again for a month or something. Yeah. And then let's take a look at the realistic example. So our scoring server runs the CTFD framework at this address. And then it has a login feature. And then after you log in to the website, if I send the HTTPS request to this website, so that this is the showing that the network transactions of the web browser. And then it sends a GET request to this website. And then in the request header, the web browser recorded the session ID here. So this kind of value will always be included into every request so that server can identify who you are. Yeah. And then that does not leak any kind of username or other information because this is just a random number. And then all that kind of information will be stored into the server. And then server will get that cookie value and then use it to retrieve the session. Then finally, server knows that which user it is. And then we will also take a look at how CTFD processes the username and password for login. So the good thing about the computer science is that for the other engineering things, even if there's any working example, you cannot take a look at all the details. But the good thing about the computer science is that most of things are open source, so that we can actually take a look at every single lines of the source code to examine what's going on under the hood. So this morning, I hovered over the CTFD framework, and then I take a look at I excerpted what they are doing. So whenever the username and password has been submitted to the a CTFD framework, and then they try to use the query filter by name, and then internally this name will be escaped with the cursor execute. So that's why there's no SQL injection in the real CTFD website. So the SQL injection that you can play with it looks like the CTFD login, but that's what I created insecurely. So that's why the SQL injection works for that login dialog. But for the main login dialog for our scoring server, it does not work. The reason is, so the framework automatically sanitized all the strings, and that's why. And then second thing is, whenever we type the username and password, and then they run the verified password with the username, and then what they are doing is that they are running SHA-256 to verify the password. Yeah. So they do not store the plain text password. They actually store the encrypted password on it. So actually hashed password. And then after user got verified with the correct username and password, what they are doing is that the session that regenerate. So there is a server session for that specific user. So with no login, this user is nothing. And then when the login happens, then it will generate the new session and then do the login user. And then what login user does is for the session, it stores a user's ID, user's name type, those kind of information. And then next time our browser connects to the scoring server, and it will send the cookie as a session ID, session value. And then the CTFD framework will fetch that session as this session variable. And then by accessing that with the ID name type, we can fetch the correct login user information. So the important thing is that all these plain text information is stored on the server side, and then client has no control over that. And then some of the menus, for example, get into the settings or the My Score, that kind of features are not available for non-login user. And then how CTFD handles that is for accessing to settings, it will invoke this function, but it has this kind of the decorator. And then decorator in the Python is that whenever we run this function, it will run this decorator first. And then what this decorator does is it says authenticated user only. And then in the function, it will run this, and then it will run auth as to check if the current user has been logged in or not. And then in the auth function, what it does is it will check if the session's ID value is false or not. Yeah. So if it is false, no. So actually it returns true for the login user, and then false here means that if there's no value, then it will return false. And then what we are doing for login user is that we put the user's ID. So that's actually the number. So I have the number 0 because I was the first user for our scoring service system. And then starting from user number 2, some of the students got assigned. And then it will store that kind of number to the session if the login has been passed. Otherwise, the session will have no value. So that's how the server can check whether the user has been logged in or not. Any questions about this kind of the mechanism within the CTFD server? And for your information, CTFD uses Flask as a web framework, and then it supports like several APIs and tools that we can sanitize the input and then use the database and all sort of those kind of things. And another thing is logout. So that's also important. So if we get into logout, yeah, and then if the current user is authenticated, then log out the user, and then logout user means that they clear the session. So remove all the values from the session, then this will return false. So the server can know that the user has not been logged in. That's how it works. And then now you see that if you have the valid cookie and then deliver that to the server, then server will fetch the session data and then regard you as a legitimate user. Then what we can think of is, as you mentioned, so there's a problem if the cookie value has been stolen. So malicious client can steal the cookie, and then suppose I stole one of the cookie from you, and then try to put that in my browser, and then send the request like this. Then it'll be delivered to the server, and then server don't know whether I'm a malicious client or not. They just have a trust in this kind of cookie. And then because they just gave it to the specific user using TLS, so that they are believing that only the user knows it, but that assumption never holds because user's computer can be hacked, or there are several ways that we can steal the cookie. Yeah. So the problem is that it will use this cookie value and then fetching sessions with the cookie, then it will return legitimate user ID, then you can be that user. So on the server side, they all got the legitimate information. Yeah. So although we protect the password and then all those kind of things, if we cannot protect this kind of the cookie value, then we cannot get done about like authentication correctly. So this is so-called a session hijacking attack. So client logs into the server and then they will create the session, and then that is managed by the cookie value. And then if the attacker can steal the cookie, then that's resulting in a session hijacking attack. Yeah. And this is because the server maintains all the client status, and then that is accessed solely by cookie. Yeah. And then cookie is transferred plain text in the HTTP. So if you are using HTTP for cookie, then all the middlemen can also see the cookie. But thanks to HTTPS, most of the websites are right now running with the HTTPS. So the middlemen can never see the cookie, but there are several ways that we can misuse this kind of the cookie. And then from now on, we will learn about those kind of attack. And then before that, the implication is that the cookie is actually the receipt of the valid transaction. Yeah. So if the attacker can steal that receipt, then they can validly authenticate that I'm that user. Yeah. So that's definitely the security credential. So we need to protect that, and then we prevent all of the abuse to that to protect the authentication. And then for the next, I will give a little demo. Yeah. Then how the session hijacking attack works. Yeah. And then after the demo, I will move forward to the 2 new attacks. So what I'm actually doing is I'm instantiating a web browser, Firefox, and then I will connect to our scoring server. But I will use a special program called a web proxy. And then whenever a web browser makes a request, I will stop it here and then try to examine it. And then I will make some of the edit at here and then send that to the server. So it's something like having a hook before the sending any kind of traffic. And then we can have a chance to edit that. And then this program burp is doing that. Then there's a proxy. And then to use that, this one, what you need to do is you need to go to the web browser setting, and then you need to set the HTTP and HTTP proxy to go to that kind of the application first before hitting the server. So what actually does is whenever Firefox makes a request, that will go to this application first, and then this application will mediate all the communication between the server and client. So you can think it as that this application is a hacking tool for launching man-in-the-middle attack. Yeah. And then what I will gonna do is, I will go for our scoring website, but I will log into the different user. So now I'm logged in with the username red9057. Yeah. And then I will also connect. So logged in session is available on Google Chrome. And then I'm using Firefox. Then try to connect to there. And then you can now see that this browser has not been logged in. So it says login button because logged in session shows that logout button. And then if we connect to the user page, it says we need to log in, right? Then I will assume that attacker compromised my computer and then try to steal the cookie. And then how can we see the cookie is that, so just open the developer's inspection tool on the browser and then click for the network and then refresh. Then you can see all the network transactions are here. And then just take a look at the first one. Then there's a request header. I'm not sure whether you can see the text. I cannot. Oh, I can increase the text size. Nice. Yeah. So what it shows that what was the request? So the request was I'm sending the request to the user page of the scoring service, right? And then in the request header, because whenever the cookie was assigned, then our browser will store that and then use that for the connection to the server, so that they do have this kind of session number. So that I will steal the session ID entirely. Yeah. And then what I will do is I will connect to the same user page in Firefox without login. But in this case, I will intercept the traffic. So right now I intercepted the traffic to the CTF, that unexploitable system, HTTPS. That's why the port number is 443. And then it has a cookie value, but this session is invalid. Then I will change this cookie value to the value that I stolen from the Google Chrome. Then I will click forward. they regard me as the same user logged in the Google Chrome, right? So servers are done. What they are doing is like they give the cookie number as a receipt, and then they just check it. Yeah. So this is the demonstration of the session hijacking attack. But the problem is that I use the developer's tool to easily steal the cookie value. But to actually launch the attack, you need to compromise my machine. Yeah. Question?
So when you make the request to the server, only capture your cookie value and
No.
so if you just brute force like just requesting random generated session IDs, like it.
So in that case, so this number is actually it looks like the 128 bits. And then to brute force it, you need to send like a 2 to the 128 request. Yeah. So that's the thing. So the important thing is like that we need to have a long random number cookie value. No, or like if you just have like the random number in range 0 to 10,000, then that kind of brute force attack can easily work.
So if I have to pick try to log in Facebook and
so that's a different thing. So to think about it, so I mentioned about the Bitcoin mining rig for the brute forcing the hash value. So the brute forcing hash value is all operated locally. There's no network connection. For this thing, you need to make a network connection to the server. Yes. Right. And then even if you have like a huge number of the servers, and then if you send that request from one location, then they can easily get like this single IP or range of the IP from the Oregon state, sending like a 2 million login request. And then they can catch it as a fraud detection. But to actually launch that, how you can do it without caught by the servers are, you need to hack many machines and then let those kind of bots connecting to the the login server from the anywhere of the world, then it's very hard to defeat that. Yeah. So this is the demonstration of the session hijacking attack. Then we will go back to the slides. All right. And then next, we will learn more about the two new attacks called the cross-site scripting and cross-site request forgery. And then we just have seen that the session hijacking attack, and then the case was like you guys need to compromise my machine. And then with using these two attacks, what we can do is we can steal the cookie. Maybe let me move this one somewhere else. Oh, I cannot click on it. Now I can move it. All right. Yeah. So using cross-site scripting, and then cross-site scripting is something like similar to SQL injection. So the SQL injection is like injecting input to SQL query. And then the cross-site scripting is that they're injecting client input to the JavaScript code. And then JavaScript let attackers run some of the programs, and then actually they can access cookie, and then attackers may steal cookie by using this method. And then another type of attack, cross-site request forgery. Yeah. So, So what it does is it does not have any kind of restriction. You can write your own web page, and then just making the user comes to the web page, then you can actually launch some of the attack. And then the second attack is much more stronger because you don't need to steal the cookie, but you can still abuse the client cookie. And I'm sure that you guys are not currently clear about what these means, but you will be clear in 30 minutes. Let's go. So before getting into the attacks, let me describe a little bit about how our web was developed. So World Wide Web was coined in early 1990s, and then at that era, we didn't call it as a Web 1.0, but in 2005 or 6, they coined like a Web 2.0, and then now we are living in a world with Web 3. So later we call it the old one as a Web 1.0. Yeah. And then what's the characteristics of the Web 1.0 is that, so web at that time was like just the client send the request and then server response. That's the only feature. So what that means is that, so client can send HTTP request to the server. And then after they receive it, and then that's it. And then to interact with the server, they need to make another HTTP request. So that either they need to, so that they need to move to another page to get the updated data. So that think about it. So that right now on Facebook, whenever some other people press like button, then there's a notification icon, and then that alarms us that there was a like button clicked for me, right? Yeah. And then that is updated by the server. Also think about it. So Facebook has a chat feature. And then if one of you send message to me, then the server will send that message to me. And then that kind of thing is not possible in Web 1.0 because it is always the client send the request and then server send back. So in 1995, there was like the web-based chatting services. And then how they were implemented was, so the client will refresh their website on every 1 second or something. That's how the client can fetch the new data. They need to refresh the entire page again and again. Yeah. Because there's no way that the server can initiate the communication, or there's no way the client fetch new data without refreshing the web page. So it is so inconvenient. It's more likely static data. So something like my homepage, course website kind of thing. So there's no chatting, no notification, no sharing, and then it server just to give the data to you, and then that's it. That's the Web 1.0. So I just explained that the Facebook or other applications. So we have many web applications that the server keep us notify and then client fetch the data dynamically. And then without refreshing the entire page, we can get new posts as we scroll by. So that kind of thing is possible. But in Web 1.0, there's no standard way to do so. So the developers are arbitrarily making that kind of thing possible. For example, like refreshing the page every 1 second or something. Yeah. And then we now have a Web 2.0. And then what the biggest change in the Web 2.0 is that they added dynamic network accessing available in JavaScript space. So what that means is that whenever client connect to the web server, it will fetch the HTML data. And then in the HTML data, we could include the JavaScript code. And then that JavaScript code can call a function called XML HTTP request that dynamically send the HTTP request and then get the data. So the HTTP itself has not changed. So the client always need to make the request. But the different thing is that we don't need to refresh the entire page. So page stays there. And then, so for example, so suppose you are on the Facebook and then you scroll down the recent post. And then whenever it reaches to the end, then the JavaScript code will call this kind of the XML HTTP request to fetch the new data and then display smoothly that you can continuously scroll down the unlimited number of posts. Yeah, that's how it works. And then Web 2.0 is not just about like the enabling the dynamic network data fetching. So that's the most important part for us. But it also has like the features such as like a WebSocket. If we use WebSocket, then server can initiate the communication. So that's how we can enjoy the chatting and the notification and then that kind of the real-time interactions with the web server for now. And then it also has like many other features. WebGL runs for the running 3D graphics on the JavaScript space. and then WebCL is for like the using the GPU calculation for the at the JavaScript, and then because all the efforts is more likely previously we download some of the application and run on the system, but in these days we just connect to the web and then we use the web application. And then the reason why we can enjoy that kind of the full-fledged web application is that they can, whatever they can do is thanks to the Web 2.0. Without having that, we cannot have that kind of the interactive application on it. Yeah. And then how they can get the new data is that, so suppose client just connect to the Facebook website, then they will fetch index.html. And then inside the HTML tag, there's a lot of script source. And then that means we need to load the JavaScript from that kind of the website. And then client will load the JavaScript. And then after finishing loading up the web page for Facebook, and then JavaScript code, and then they will run it on your client browser. And then the JavaScript code will continuously fetch the new data by using the XML HTTP request. So that you can regard it as if you can get onto the JavaScript space, then you can make any kind of the HTTP request with Web 2.0. Yeah. And then examples of that is, so that this is the JavaScript code. And then if you want to send the HTTP GET request to this URL, and then some of the header information as an authorization token as this one, then we can put the URL, put the method by creating the XML HTTP request object, and then set the header and send. And then by running this code will access this website using HTTP. Yeah, and then it will send authorization vector like this. So the implication is that in Web 2.0 and onward, so JavaScript code can fetch the new data, and then JavaScript code can initiate a new connection to the other website without having any kind of visible queue. So in Web 1.0, we need to refresh the web browser. So we can see that web browsers are keep refreshing, something like that. But in Web 2.0, we can make the new request completely hide-lessly. That's the background. And then the reason why it is important is that, so now we will learn about we will inject JavaScript code into the website, and then we will run some code to make a new request on behalf of the user. And then that request is coming from the user's browser, then it will automatically attach with all the valid cookie. Yeah. So now we will learn about the cross-site scripting. And then it is abbreviated as XSS, cross-site scripting. And then to get to the cross-site scripting, the background of that is likewise the SQL injection. There's a way that the attackers can inject a JavaScript code into the website. And then if that happens, thanks to Web 2.0, we can make a HTTP request using XML HTTP request. And then if we connect to OregonState.edu or unexplorable systems, then your browser will use a stored cookie value to connect to the server. Yeah. Then if the attacker can inject code to the JavaScript space, then they can make a request to post, pressing delete post, or any kind of the request, so that they actually can become a user. Yeah. And then let's learn about how this can happen. So let me present about the very basic of the Web 2.0, which was the insecure version at the start. So if you want to do code injection naively, what we can do is, so as an attacker, we can create a new website. So for example, I got the domain attack.com, but it could be anywhere. So that you just create your own website. There's no hacking needed. Just rent the cloud machine and then put your HTML. That's it. And then ask any other student here or like myself or some other victims to visit your website. And then what you will do is inside of your website, you will try to make the XML HTTP request to send the request to some of the bank website, send the money, and then put the recipient as myself and then send the value. And then even if you connect to my website, if I make that request, your browser has the cookie for Wells Fargo, Chase.com, or something like that. And then if I make that request to that server, and then your browser will use the cookie stored for that. So that if you have login to the wellsfargo.com, maybe 15 minutes before visiting that website, and then that website may send a request for that, then it'll be problematic. So the attacker never hijacked the session, never hijacked the cookie, but by just launching the JavaScript code to connect to the specific website, then they can reuse existing cookie in the client sessions. Yeah. So this looks super dangerous, right? So this never works. And then the first thing that Web 2.0 blocked is this kind of attack in 2005. And then the one of the policy actually kills that. And then that's so-called the same origin policy. And same origin policy is there for like they're doing many things, but specifically they block this kind of the naive code injection attack. Yeah. So for the naive code injection attack example, that's attacker can create any kind of website. So if I write a blog post and then if I hide some of the the JavaScript in there, then I can hack all your account for the other website. So that should never happen. So to block that, the same origin policy by this name states what it does is, so the problem is like the victim was connected to my website, but why should we allow that website to make connection to the google.com, chase.com, wellsfargo.com, the other websites? So the policy is JavaScript from one website can only access their domain only. It should never go outside of the domain scope. So if you connect to the attack.com, then with the XML HTTP request, you should only send the request to under that domain, not about the different domain or banking website. So that's the same origin policy. And then to learn more about the same origin policy, you can search about that. And then some of the example of the same origin policy is that, suppose the main website that we are connecting is store.company.com. Yeah. So if we get into this JavaScript space, then we can make a request to this website because it has the same domain. So the rest of the path could be different, but the important thing is like the domain name is the same. For this one, we can also make the request because the domain name is the same, and the same thing, domain name is the same. But for this one, we cannot make the request because the web page was HTTP, but this website is HTTPS. They regard the two things are different one. It's not in the same origin, so we cannot make the request to here. And also, we cannot make request to this domain port 81, so that actually specifies another domain. And then if that's the completely different domain, it's also unallowed. Yeah. That's how same origin policy protects the user from that kind of a naive code injection attack. So that you don't have to worry about that attack. But at the end of this lecture, I will introduce a similar kind of attack that still works, yeah, but in a different fashion. So the important thing is that we cannot hijack sessions using XML HTTP request because the same origin policy blocks that. So if we create our own website, then what we can do is like we can make the request to our website, not about the other's website. Yeah. Then we need to break the same origin policy, or we need to follow the same origin policy. So the next step as the hackers, what they did is they didn't break the same origin policy. And then they tried to find a way to inject the code to the target address space. So for example, to attack Facebook, what if they can find the vulnerability that they can inject the JavaScript code in facebook.com? Then they can be in the Facebook origin, and then they can make any kind of query, HTTP request to the facebook.com. And then let me show you one of the example. So this is the virtual example. It does not work for now, but it has been worked for like the 2003, 4, 5-ish. Yeah, but in old days. But let me introduce one of the attack. So this is the one of the example of the Facebook post. And then in the post, there could be a lot of comments like this. And then this is the code of the comments. So I use the developer tool to examine that. And then the same text is here. So my question is that what happens if you write a comment like this? So in HTML, this is a script tag. Then the command is like the running this code. And then alert is like the popping a dialog. And then as a content, give me the cookie. So something like I try to type this kind of string as a command. Then the HTML interpret the string like this. And then after they see new tag, yeah, they will interpret this part as a JavaScript code and run it. So because the Facebook blocked that kind of attack in very early days, so this is not working. But if it is not blocked, then like this kind of attack still works for some website. Yeah. So this is so similar to the SQL injection, right? For the SQL injection, we need to cut the quote for that. But in the HTML, there's no need for that. So if you have a tag, then it will automatically interpret that as a script tag and then run it. So that's how you can inject JavaScript code. And then may I ask how on the server side we can defeat this kind of attack? That's right. We learned about the SQL injection. We can sanitize the input. So for this kind of input, we can sanitize this kind of the brackets because that indicates HTML. And then I told you that don't ever write your own sanitization algorithm. So there are like the some HTML escaping functions, so-called HTML entities or something. Yeah, then it will securely escape all the special characters for HTML and then make the strings printable as a text. Do you have a question?
Can I ask a question? So we're only able to retrieve the cookie because we know what like they coded it as because it's document.cookie. Wouldn't like hiding those values also be a method of like not like complete security, but like a little bit more?
So from JavaScript, what you can access is a cookie, and then you can also access like the entire content of the website that you have on the client side. But the real username or that kind of thing is stored on the server side. We cannot alter that, but at least we can control all the things on the client side. Yeah. So I just demonstrate that there is a way that attackers, if the site is vulnerable, there's a way that the attackers can inject JavaScript into the Facebook space. And then the code itself running on the facebook.com, that means in that JavaScript space, we can make any kind of request to anywhere under facebook.com. So easily we can log out the user. That's the benign one. But we can actually make the false post and then like delete some of the posts and then writing some of the bad vulgar comments. That kind of thing has been possible. And then like, if you search on the news for that, you will see that Mark Zuckerberg has also been hit by this kind of attack. And then some of the hackers can post some of the weird messages on his account. Yeah. And then they did not hack the server. Actually, it's something like hacking the server. They actually implement JavaScript interpretable comments or posts, something like that, and then send that to Mark Zuckerberg. And then whenever Mark Zuckerberg reads that with their browser, then that code runs in, and then that is completely done on the browser side. And then server don't know because that kind of request comes to with the legitimate cookie. Yeah. So that's why the server has processed like the posting of all those kind of the weird articles. So after the code injection, what attackers can do. So as I just mentioned, so in the JavaScript space, we can access anything on the web page. So I just show you that like I can open the developers tool and then examine about the HTML tree kind of thing. So that's actually possible in the JavaScript space. So the attackers can do anything. So I just demonstrated document.cookie, but the document.getElement by ID, so that will locate like a password box or something. And then you can actually steal the password, even if like that is shown at the ... as a scrambled. In the JavaScript space, if you get the password form and then access that value, then you can get the plain text value for the password. So that kind of thing is possible. Yeah. And then because you can access all the elements in the HTML, so you can basically put the photos, write something, and click the post button. So you can technically, what user can do, you can technically do whatever user can do on the web for that website. Yeah, in the JavaScript space too. Yeah. And then the most important thing is that same origin policy can never help in this case, because what we are running, the domain that we are running, the JavaScript code is the same website. Yeah. So this is a serious attack. And then the Facebook attack example does not work. And then the reason is, so have you ever heard about the bug bounty program? Yeah. So there are many companies, they are like hard to spending much money for the security. And then what they are doing is like let hackers hack it first. And then if that kind of hackers report about the security vulnerabilities, and then they pay the bounty. And then in a few years ago, a hacker found a cross-site scripting vulnerability, and then Facebook paid $20,000 for it. Yeah. So like in these days, because the web framework has also been developed a lot for the security, so it's quite hard to find this cross-site scripting vulnerability. And then I also have the experience about like the getting bounty from Facebook, but it was 2013 or something. And then at that time, like there were a lot of cross-site scripting vulnerabilities were there. And then I submitted one, and then they just paid $500 to me. Yeah, but because like at that time, like there were so many vulnerabilities. But in these days, the finding that kind of vulnerability is much more harder. And then like from 2013, after 9 years, our web framework and then web application developed a lot. Then now Facebook is used for logging into another website or something. So the hacking in Facebook with the cross-site scripting, we can actually authorize like the sign into another website with that. Yeah. So that could be another problem. So like they raise the like bar for that, while like they are defeating all the attacks. They also pay out like a huge bounty for the attacker, like the hackers, white hat hackers, to incentivize like finding such vulnerabilities. Yeah. And then another thing that you can see is like what they do is just running the JavaScript code. So like they injected the JavaScript code, and then like to some of the mechanism that allows the cross-origin communication, so that this hack can connect to any kind of the Facebook website from there. So they actually play with the JavaScript a lot to demonstrate whether they can hack first. Yeah. So what I did is like not that different with what hackers are doing. Yeah. So like you should never hack the other's machine, and then if you found any kind of vulnerability, you should report to the vendors or like the US CERT, yeah, where like the manages all the vulnerability report and then let the vendors patch about that. Yeah, you need to do that kind of thing. But so please do not use this kind of the technique for the bad ways. But what I recommend is like if you want to find a bug, yeah. So I'm saying something ironic. So every time I go to the new website, I tried this kind of thing first to check if that's vulnerable or not. And then like in my right now it has been changed, but in my Instagram account, I was testing that in 2014, and then for 5 or 6 years. So all the testing strings for the JavaScript code kind of thing was on my profile. Yeah. Yeah. So please do that for examining the security or vulnerabilities for the website. But if you found a vulnerability, do not exploit that, and then please report to the vendors. Yeah. And then, how can you defeat that kind of attack? So the one easy answer is that it is the injection attack, so we can sanitize it. So the web frameworks are supporting like a lot of the APIs. So the one of the thing in PHP was like called as HTML entities, and then like you can search for the HTML escape or something like that, so that you can easily find the API for like the preventing the cross-site scripting. Yeah. And then like even if I told that like it's very hard to find the cross-site scripting vulnerability, but it happens a lot arbitrarily. So please don't give up. And then like if you want to be a vulnerability hunter and then submit something for the bug bounty, then like please try to inject that kind of weird thing. But please don't do that to the other user's account. So that whenever I test Facebook, I create the Youngjin test 1, Youngjin test 2, 3, and then try to hack inside of that kind of group, yeah, to not affect to the others. Yeah. And then like there are some of the rules about the bug bounty, because even if like the vendors let the hackers work with some of the finding the vulnerability freely, there should be some of the rules to follow to not to interfere the operations. So to read more about that kind of the rules, you can visit to the Facebook white hat info, yeah, about like the reading about like what's allowed and what's not allowed, and then you can learn about like the boundary between the white hat and gray hat and black hat, those kind of things. Yeah. And then for the next, now from the document.cookie, we can see the cookie value in the JavaScript space. Then to actually launch the session hijacking attack, we need to steal the cookie. So what that means is that, so right now I demonstrated everything in here, but the actual attack setting is that, so victim is at their home. And then as an attacker, I send a comment, then victim can see. So I'm at the remote site. Yeah. And then at home in the Facebook, they read my comment, and then my JavaScript code got the document.cookie. Then how can I get this value back to me? Yeah. So the Facebook is easy. So for Facebook, if we own the JavaScript space of that, then using the Facebook chat message, send the chat to me. Then we can get the cookie value as a chatting message. But suppose there's no chatting or not direct sending method is not available. Then we need to use our JavaScript code to send that information back to me. But the problem is that suppose our server address is this kind of thing. So our server address will be definitely not facebook.com, something else. And then what we want to do is we want to get the cookie value as like this kind of the connection. So that if the victim makes a disconnection, then the attacker.com, my server, can get this value. So we want to do that. But the JavaScript code, although they can send the HTTP request, we cannot send this request using XML HTTP request because same origin policy blocks that. So now can you feel the power of the same origin policy? So even if we get into the JavaScript space of the Facebook, stole the cookie, then we cannot get back because the same origin policy does not allow sending data from the facebook.com to attacker.com. Yeah. But the hackers never give up with the same origin policy. They figured out a workaround, and then that still works because it's very hard to fix. So the one thing is that the HTML documents, every HTML documents that has URLs that the browser automatically connects. And that is loading images. So this is the example of our course website. If you get into the main web page, it shows the picture like this. And then if I examine the code for it, then it has image tag source, and then this is the URL of this image. So index.html will store this kind of tag, and then whenever the Europe web browser interprets this, then it will automatically connect to this website to fetch the image data. So go back to the JavaScript space. We cannot send the request using XML HTTP request because there's the same origin policy. But what if we add a new image as the content of the web page, and then setting the image address as attacker.com, cookie value attached as a session number? There is no same origin policy for the image access. So this is how attackers can work around the same origin policy. And then if we launch the JavaScript attack, injection attack to any kind of website, then we can include this kind of the image tag to send back the cookie value to us. Yeah. And then in the JavaScript, we can do it in many ways. Document that append child and create element. There are many ways. And then the most direct way to do that is like just making a document a write. And then it actually add the tag on the current document. And then if we just generate this kind of the URL, then it will send the cookie value back to us. And then this is the network connection example. If I run this kind of the document write, then right after I run this JavaScript code, and then it will just send request to my server, then I can easily get this part. So the implication is that the same origin policy blocks the XML HTTP request. That's good. And then due to the power of the same origin policy, we cannot use the XML HTTP request freely to send back the value, but there is a hole. And then using image tag or script source, and then iframe SRC, so any kind of that kind of the automatically connecting by the browser, we can use that kind of tag to send back the information to the attacker server. Then, if we get into JavaScript space, and then it's very easy to steal the cookie. And then we have also seen that if we have stolen the cookie, we can easily be pretending as the user, right? That's super dangerous. So the developer side does not let attackers freely doing that. So there we are learning at some of the attack and defense and attack. And then another defense is called as for the cookie, we can specify some of the cookie is for HTTP only. So the network protocol for web is HTTP. And then what we are doing is that HTML and JavaScript. So what that means is that the cookie value will, so some of the cookie, when server sets the cookie, we can set the cookie with the HTTP only. And then what that means is that web browser will attach the cookie for the HTTP protocol in the transmission, but when it gets to the JavaScript space, that value will not be shown to the JavaScript. So even if we inject into this Facebook JavaScript space, if we try to get the document.cookie, then the secret session number will never show up. They are kept only at the HTTP, and then without hijacking the network, we cannot see that. So this HTTP only keyword in cookie is for defeating JavaScript attackers from hijacking the cookie. So if attached at the JavaScript space, we can never see that cookie value. Yeah. So that's how we can protect the session ID. And then if we do so, then if we run the Java, so this is the running of the document of that cookie on our scoring server. And then if you run, so we can see this kind of session because previously we intercepted all the network traffic. So we examined the HTTP. That's why we can see this kind of session number. But in the JavaScript space, it's just a null string because everything is HTTP only. So this is how the server side can defeat the JavaScript injection attack for the session hijacking attack. But still, if we inject the JavaScript code to the client, even if we cannot steal this kind of cookie, they can still write the post or like the what user can do, because that's just executing some of the code in JavaScript. Yeah. So let's do a little summary before moving on to the final attack. So the cookie, so we use cookie for maintaining the status between the client and server. And then all the status will be stored on the server side. And then when the login has been passed, login check has been passed, then the server will generate a receipt to provide that the proof of like the login. And then that's cookie. And then server will only see cookie to continue to get identify the user. So if the cookie value got hijacked by an attacker, then the attacker can pretend as like that target user. And then on top of that, we learned about the cross-site scripting. And then if not sanitized properly, we can inject the JavaScript code into some of the website. And then there are same origin policy so that we cannot arbitrarily create our own website to attack the other banking website. That's not possible. So that's why attackers want to inject the code to that space. Yeah. And then once injected, we can do whatever user can do on that website. And then if the cookie value is available, we can steal that, not using XML HTTP request, because that's blocked by the same origin policy, by just using image tag to get the value back to us. And then hackers are doing that. So the defenders would like to block that. And then how they do that is like they implemented HTTP only flag in the cookie. That was not there before 2008, I believe. Yeah. So after implementing that, session hijacking gets more harder. Yeah. Any questions up to like a cookie, cross-site scripting, and session hijacking attacks? All right, and then I will move on to our final part for today. Yeah. So the next attack is so-called the cross-site request forgery. And then the CSRF is an attack. So we call it as a CSRF or XSRF because some cases like we use X for that. And then that's the attack that attacker may misuse victim's valid cookie value, but it's not caught by the same origin policy. And then it's not about the stealing the cookie. And then it's not about the injecting the JavaScript into the victim's website or something. So the attack is very easy to launch, as like I mentioned about the knife injection attack. And that still works. And then let's take a look at the why and then what is cross-site request forgery, and then why it works even if we have the same origin policy, and then even if the attackers have not stolen the cookie. So recall about the image tag. So whenever we have this kind of tag, then your browser will interpret this as an image tag and then try to load this from the website. So it will actually make the GET request to there. So that this is the result of my web browser after executing document the write for this kind of tag. So if there's an image tag, when you connect to some of the website, there's an image tag, then your browser will automatically send the request to there. Yeah. So, and then when I did that, it will send the request. But interestingly, because your browser will keep track of all the cookies was issued from the server to your browser, and then it maintains per each website. So the suppose user has been logged into the Microsoft account that being also honors that. Then for this kind of the image request stored in my website, it will automatically use stored cookie value of the user and then make the request. Yeah. So it's something like, I didn't steal the cookie. I just create my own website. And then at the end of the page, I created this kind of the image tag as a 1 pixel, then you will never see that. Yeah. And then put a lot of this kind of thing. Then whenever you come to my website, then it will send a lot of requests to bing.com. Then they will use the active cookie that is remaining in your browser. So the implication is that, so we can make the victim's browser to connect to the specific URL using image source. Yeah. And then we can even write that in our own website. Yeah. For example, I can write maybe I can hide some of this kind of attack in my course website. And then whenever you visit there to download the slide and watch the video, then you're hit by this kind of attack. But don't worry, I did not put any of that. Yeah. And then this capability actually let attackers send any kind of GET request. So in HTTP, the two most important requests is the GET and POST. And then the difference between the GET and POST is that GET does not have the data. So if we want to log in with the GET request, we need to put all the parameters, ID and password, in the URL. Yeah. But the POST request is different. POST request does not send the parameters. So after this question mark for the POST request, it does not have on the URL. And then POST request, we can send the data. So in the data part, we store this kind of thing. But the important thing is that using the image tag, we can only send the GET request. Yeah. That's the important thing. And then let me demo one thing about that. I can easily write a website that makes you from log out from our scoring website. And let me show you about that. So right now I have logged in with the red 9057, right? And then I can see the challenge, and then I can also see my score. Then, and I'm using a different browser to check, to show that what I have been done. So I'm not sure how many of you have known this. So I secretly hide one more menu in here, and then if you click it, and then it says like they will give all the answers, but it's totally a lie. And then like shows that this kind of video. And then do you know what video it is? Yeah, so this is called the rig rolling, and then like I just play with that kind of thing. But the more important thing here is that, so I inserted an image tag in this page. So image with 1 pixel height, 1 pixel width. So it's just a dot. You will never see that visually. And then what it does is a source, HTTPS scoring server, and then do logout. Yeah. And then I just do that. And then for this one, it has been logged in, right? Then what I will do is I will visit this website. I visited there. Refresh this one. It's been logged out. You can do that again. You can do the same thing. It doesn't harm you. So like visit this re-rolling page, then it will immediately log out you from the scoring server. Because when I actually wants to log out, so can you see at here that what it does is like a connect to log out, right? And then it works with the get request. So I just sent get request, that's it. Yeah. And then we know that what logout does is that it does not care about whether that's a GET request or POST request. There's no specification. So it accepts GET request. And then what it does is like if the current user is authenticated, it log out to the user. And then what we are doing is that on my web page, when you connect it, and then I will send the request to our scoring server, but your browser will automatically attach the cookie for it. And then that cookie says that that's a valid user. That's how like the logout happens. So I just demonstrated a simple feature logout, but it could be more than that. Not about the logout. There could be some of the functionalities, and then gets the parameters for sending money, recipient and amount, for the banking side. If they get with the GET request, then we can actually launch the attack with that. Yeah. So technically, any kind of GET request that user can do some of the action, as an attacker, we can do that. Yeah. So the implication is that it's just a logout function that I just demonstrated, but conceptually, attackers can do any kind of operation that is accepted with the GET request. Yeah. And then another interesting thing is that let's think about the requirement for this kind of the cross-site request failure attack. So for cross-site scripting, we need to find the vulnerability to inject the code. And then nowadays that costs like a 20K as a bounty, right? So that means it's quite difficult. But in this attack, we write our own website. There's no restriction. It does not cost $20,000. Yeah. And then what we need to do is just to lure the victim. Yeah. Oh, visit my website. That's it. Then we can automatically send all the thing. And then we don't need to steal the cookie. We don't need to find the vulnerability. So the attack is very easy to launch. That means it's so dangerous. Yeah. And then let me give you another example, another interesting hack, that we can manipulate the user with the cross-site request forgery attack. So we can actually manipulating the search result of the Bing website. So you might feel like this is very weird. Then how come, right? So we can actually do that. The reason is, so the Bing search engine, or also for the Google search engine, they accept the search query as like a search, and then Q equals shoes. And this is definitely GET request. Yeah. And then this will search shoes like this. But the interesting thing is that the search engines are customizing the search result based on the user's activity. So for example, if you click some brand link, then it will rank up. So in the previous screen, we cannot see Nike or something like that. So the Nordstrom comes first. But if the user searches Nike, ASICS, Aldo, or some other brands, and then those kind of the depending on the how many times you search on it or clicked on the link or something like that, they rank up the some of the search result. And then what I can do is I prepare a website and then write a blog post, maybe a giveaway of the $50 of the Starbucks gift card, just to like give a try or something like that. Yeah. Then many people will come, and then I can insert tag for the searching for the Nike shoes for 10 times or multiple times or something like that. Or if I launch the Youngjin for the shoe brand, then I will search for the Youngjin shoe for multiple times. So this is not working right now, but in 2013, if I do so, after searching shoes, Nike comes first. Because from Bing's perspective, I used a valid cookie for the Bing, and then the victim keep searching Nike, Nike, Nike. Yeah, that is recorded into the server, and then server honors that data. Yeah, so that we can actually manipulate the search result for the ranking. Yeah, by running like this kind of attack. And then this attack was implemented by one of my colleagues while I'm doing PhD at Georgia Tech. So like it was a very interesting attack. And then just preparing a website and then luring victims so they can manipulate a search result. And then if you are interested in more about this thing, please read about this paper. You can search the title in the Google and then you can easily locate that. So any question about the cross-site request forgery attack? So it's very easy, but super dangerous, right? So we need to defeat that. So one thing that I described is that like with the image tag or that kind of automatic URL, we cannot make the post request. To make the post request, we have to go through the XML HTTP request. And then the good thing about the HTTP XML HTTP request is that it's protected under the same origin policy. Only the same website can be connected by that. Yeah. So one easy way to fix that is like use the post method. So if our scoring service, their login logout page, if they only accept the post request, then we can actually manage our website. Whenever you click logout, we can send the post message to using XML HTTP request because we are in the same JavaScript domain space. But in the cross-site request forgery attack, we are in a different website. We cannot do that. So using a post method for doing something would be like one of the defense, but it's just an ad hoc. Yeah. So to kill the attack fundamentally, what other people are doing is that they are using a special token to defeat the cross-site request forgery attack. And then what they are doing is, so whenever a user comes into the server issues a random number as a CSRF token, and then make it visible to the JavaScript space. So this is not about the session management. It's just a random number to check if you are matching that number to sending a GET request. And then what server will do is for every GET request it gets from the client, it will check if like the GET request is attached with this CSRF token. And then on the server side, server gets this value URL and then cookie value at the same time. And then cookies CSRF token matches to the GET request, then it is passing. But think about the attacker's point of view. So that we don't have access to their JavaScript space. We don't have access to their cookie. So that we don't know about the CSRF token, then we cannot make a valid GET request. Yeah. So this is how the modern web services are defeating the cross-site request forgery attack using the CSRF token hidden in the cookie. Any questions for this? All right, thank you for your attention. So I almost used like the 1 hour and 48 minutes for like today's lecture. So thank you for concentrating for like a long time. Then please feel free to come down and ask questions. So I will be here for a few minutes, and then there will be no more challenges for the web and authentication kind of thing. But for the next week, I will release some of the videos for that will be helpful for the NSA Codebreaker challenge. But the important thing is like NSA Codebreaker Dana announced that nobody should be directly assisted by someone for solving the challenges. So what I will do is like I cannot directly describe about how you can solve the challenge, but what I will do is like that I will describe about some of the tools and techniques that you can apply in general for the text, and then you can find some of the useful thing in there to solving the NSA Codebreaker challenges.